Hi there, my name is Kellen. I'm a product manager for Tektronix. We're here today to talk about taking basic two-port measurements with our vector network analyzer. If you haven't watched our previous video on calibration, I'd recommend you go back and do so now. And if you have, then let's get started. Alright, so we're going to be in our two-port, two-path measurement here. And the device under test that we have is this mini circuits filter. It is a 50 ohm type N inline filter with frequency range from 1.5 to 1.62 gigahertz. Now to make our measurement, I'm simply going to connect it onto port 1. Again, our VNA has been calibrated at the port here. What I'm going to do is I'm actually going to take the end of the cable, because we calibrated to the end of this cable in the previous video, and connect it to the other side of this filter. Now if you take a look at the screen here, we're going to see that instantly, again, our device is being measured. So we're sweeping constantly across each frequency range through each one of the pathways in the device. You can see that response here. The one that I'm primarily interested in is this S21 measurement, and we're going to get to that later. Let's take a look at some of the things that we can do with the software. So instead of representing the data here as a frequency plot, we can take a look at, let's say, the display as a Smith chart by clicking on Format, expanding down to More, and clicking on Smith. And we'll do linear phase. Now you can see the phase response of the device under test displayed as a Smith chart. If I wanted to switch back, again, I'll click on Format, and I'd go back to the log mag. And we now have our standard S11 measurement. Now there are a number of other different types of ways to display this data, but essentially they're all different representations of the same plot. Now I wanted to focus on S21 here, because it'll give us some insight to the actual device that I'm testing. Now I want to blow this plot up and make it the only one visible on the screen. So I'm going to do this by reducing the amount of traces back down to 1 and adjusting my layout here so that I only view one trace. Now we're measuring S11. I'm going to change that to S21. Okay. And now I want to zoom in a little bit on our actual filter response here. So I'm going to adjust my start and stop frequencies. I'm going to change my stop frequency, let's say down to about 2 gigahertz. And I'm changing my start frequency all the way up to about 400 megahertz. I have a slightly clearer picture. I'm actually just going to move the stop frequency out a little bit more to about 2.5 gig. It's going to be a very good picture of our filter response. Now if I want to know more about the exact numbers and the exact response here, I'm going to add some markers. To add a marker, I go to Setup and I click Marker 1 to add the marker onto the plot. You can click and drag to move the marker, and you can see its appropriate response up here. Marker 1 frequency and amplitude response. Now I'm going to go ahead and add a second marker. So a common thing to do with the filter is to figure out its bandwidth start and stop frequencies by finding its 3 dB loss point. And to do that, I'm going to use the search function on the marker by clicking search. And I'm going to select marker 1 to begin with. And I'm going to do a target search. Now I put my target value here, click on target value, enter the number in the top bar. We're going to go to 3 dB. It should be minus 3 dB. And we're going to go and search right. so a search left, because there's marker number 2. So we can find the -3 dB point of marker number 2 here. We'll do the same thing for marker number 1 by clicking on marker 1. Search function, target value, -3. Click the check mark to accept, and search right. Now it finds the -3 dB point of the first marker. Now if you look at these two, you can see that they roughly correspond to the frequency ranges on the filter, -1.5 gigahertz, and then around 1.6 to 1.7 gigahertz. Again, you can use the marker functions to determine anything about your frequency response of your device. In this case, we determined the bandwidth and start and stop frequencies of the filter. So that concludes our brief overview of basic measurements with the Vector Network Analyzer. If you'd like to know more about test and measurement equipment or see more how-to videos, please visit tech.com.